Hurricane Helene, a name etched in meteorological history, serves as a stark reminder of nature's raw power. This storm, with its immense energy and destructive potential, captured the attention of scientists and the public alike. Its swirling winds and torrential rains left an indelible mark, prompting reflection on the science behind these formidable storms and the importance of preparedness. The sheer force of Helene's winds and the relentless downpour it brought with it were a testament to the unpredictable and often violent nature of our planet's weather systems. Helene's story is one of devastation, but also of resilience, a testament to human adaptability in the face of nature's fury. Communities came together, showing incredible strength and unity in the aftermath, rebuilding not just homes but lives. This essay delves into the science of Hurricane Helene, exploring its formation, intensification, and impact. We will uncover the intricate details of how such a powerful storm comes into being and the factors that contribute to its growth. From its humble beginnings as a tropical disturbance, Helene rapidly gained strength, fueled by the warm ocean waters. These waters provided the energy needed for the storm to grow, turning a simple disturbance into a formidable hurricane. Its swirling bands of clouds and powerful winds grew, transforming it into a meteorological monster. The structure of the hurricane became more defined, with an eye forming at its center, surrounded by towering clouds. As it churned across the ocean, its path became a subject of intense scrutiny, with forecasters working tirelessly to predict its trajectory and intensity. The challenge of forecasting such a dynamic system required the use of advanced technology and constant vigilance. The anticipation was palpable, a mixture of awe and apprehension as communities braced for the impending storm. Preparations were made, with homes being fortified and evacuation plans put into action. Helene's story is not just about the science of hurricanes, it's also a human story. It's about the people who lived through it, their fears, their hopes, and their determination to survive. It's a story of families huddled together, anxiously awaiting the storm's passage. The bonds formed in these moments of crisis are a powerful reminder of our shared humanity. It's a story of first responders bravely venturing into the heart of the storm to rescue those in need. Their courage and dedication are a beacon of hope in the darkest of times, and it's a story of communities coming together in the aftermath to rebuild and recover. The collective effort to restore normalcy is a testament to the resilience and spirit of the human community. This essay will explore the multifaceted aspects of Hurricane Helene, from its scientific underpinnings to its societal impact. We will look at how the storm affected not just the physical landscape, but also the social fabric of the communities it touched. We will examine the factors that contributed to its formation and intensification, understanding the role of environmental conditions in the development of such powerful storms, the devastating effects of storm surge, which can cause widespread flooding and destruction along coastlines, and the challenges of forecasting these powerful storms. Accurate predictions are crucial for timely evacuations and preparations, yet they remain a complex and evolving science. We will also delve into the aftermath of Helene, exploring the lessons learned and the importance of preparedness in mitigating the impact of future hurricanes. The experiences of those who lived through Helene provide valuable insights into how we can better prepare for and respond to such natural disasters in the future. Hurricanes, nature's swirling vortexes of wind and rain, are born from a delicate balance of atmospheric and oceanic conditions. These powerful storms can cause widespread devastation, but their formation is a fascinating process driven by the forces of nature. Warm ocean waters exceeding 80 degrees Fahrenheit provide the necessary fuel, evaporating and rising to create an area of low pressure. This warm water acts as the energy source, much like gasoline fuels a car, driving the storm's initial development. This rising air cools and condenses, releasing latent heat that further fuels the storm's growth. The process of condensation releases energy, which in turn heats the surrounding air, causing it to rise even more rapidly. As the warm, moist air continues to rise, it creates a spiraling pattern of clouds and winds, the hallmark of a developing hurricane. This spiraling motion is a key characteristic indicating the storm's increasing organization and strength. The Earth's rotation plays a crucial role in shaping the hurricane's characteristic spin. Without this rotational force, the storm would not develop its distinctive cyclonic structure. The Coriolis effect, a consequence of the planet's rotation, causes winds to deflect to the right in the northern hemisphere and to the left in the southern hemisphere. This deflection is essential for the storm's rotation and overall development. This deflection imparts a cyclonic rotation to the developing storm, giving it its signature swirling appearance. The more pronounced this rotation, the more organized and potentially dangerous the hurricane becomes. Favorable atmospheric conditions, such as low wind shear, are essential for hurricane formation. These calm conditions allow the storm to build vertically without being torn apart by varying wind speeds at different altitudes. Wind shear, the change in wind speed and direction with height, can disrupt the storm's vertical structure, inhibiting its development. High wind shear can essentially decapitate a storm, preventing it from growing stronger. When wind shear is low, the rising air can maintain its vertical momentum, allowing the storm to strengthen and intensify. This uninterrupted vertical growth is crucial for the storm to reach its full potential. Without these specific conditions, a hurricane cannot form. The absence of any one of these factors can prevent the storm from developing or cause it to weaken. As the storm intensifies, it progresses through a series of stages from a tropical disturbance to a tropical depression, each stage marked by increasing organization and strength, then to a tropical storm, where wind speeds increase and the storm begins to take on a more defined structure, and finally to a hurricane with sustained winds reaching at least 74 miles per hour. Each stage is marked by increasing wind speeds and a more organized structure. The storm's eye becomes more defined, and the surrounding eye wall intensifies. The Saffir-Simpson scale categorizes hurricanes based on their wind speed, ranging from Category 1, the weakest, with winds of 74 to 95 miles per hour, to Category 5, the most powerful, with winds exceeding 157 miles per hour. These classifications help communicate the potential impact of a hurricane, aiding in preparedness and evacuation efforts. Understanding the scale and potential damage can save lives and reduce property loss. Helene's story begins as a seemingly innocuous tropical disturbance, a cluster of thunderstorms off the coast of Africa. Fueled by the warm Atlantic waters, this disturbance began to organize, its winds gradually increasing as it drifted westward. As the storm moved over increasingly warmer waters, it underwent a rapid intensification, transforming into a tropical depression and then a tropical storm. The National Hurricane Center, tasked with monitoring and forecasting these meteorological behemoths, kept a watchful eye on Helene's progress. Forecast models churned out predictions, projecting its path and intensity. As Helene continued to strengthen, a sense of urgency grew among coastal communities in its projected path. Evacuation orders were issued, and residents began preparing for the impending storm. Helene's intensification was remarkable, its winds reaching hurricane strength in a matter of days. The storm's central pressure plummeted, a sign of its growing power. The swirling bands of clouds tightened around the eye, the calm center of the storm, creating a vortex of immense energy. As Helene churned across the Atlantic, it became a force to be reckoned with. The storm's rapid intensification was attributed to a combination of factors, including the exceptionally warm ocean temperatures and favorable atmospheric conditions. Low wind shear allowed the storm to maintain its vertical structure, while the warm, moist air provided ample fuel for its growth. Helene's journey across the Atlantic was a testament to the complex interplay of atmospheric and oceanic forces that shape these powerful storms. Section 4. The devastating surge, Helene's wrathful waters. One of the most dangerous aspects of a hurricane is the storm surge, a rise in sea level caused by the storm's winds and low pressure. This phenomenon can lead to catastrophic consequences for coastal regions. As the hurricane approaches land, its powerful winds push water towards the shore, piling it up against the coastline. This relentless force of nature can overwhelm barriers and flood defenses. This surge can inundate coastal areas, causing widespread flooding and destruction. Entire neighborhoods can be submerged, leaving residents stranded and in peril. Helene's storm surge was particularly destructive, impacting low-lying areas with devastating force. The sheer volume of water displaced by the storm was unprecedented. The height of the storm surge depends on several factors, including the storm's intensity, its forward speed, the shape of the coastline, and the angle at which the storm makes landfall. Each of these elements can amplify the surge's impact. In Helene's case, the combination of these factors resulted in a significant surge that inundated coastal communities. The water levels rose rapidly, catching many off guard. The rising waters swept away homes, businesses, and infrastructure, leaving a trail of destruction in their wake. The aftermath was a stark reminder of nature's power. The impact of storm surge is not limited to coastal areas. The surge can travel far inland, affecting regions that might not typically expect such severe flooding. The surge can penetrate inland, flooding rivers and streams, and causing further damage. This can lead to secondary flooding events, compounding the disaster. The combination of storm surge and heavy rainfall can exacerbate flooding, leading to widespread devastation. The dual threat can overwhelm drainage systems and natural waterways. In the case of Helene, the storm surge combined with torrential rains to create a catastrophic flood event. The resulting deluge was unlike anything the region had experienced before. The destructive power of storm surge underscores the importance of understanding and preparing for this hazard. Awareness and preparedness can save lives and reduce damage. Evacuation orders are often issued for low-lying coastal areas in anticipation of storm surge. These orders are based on careful analysis and predictions. Heeding these warnings is crucial for protecting lives and property. Timely evacuation can mean the difference between safety and tragedy. Building codes in hurricane-prone areas often incorporate measures to mitigate the impact of storm surge, such as elevated foundations and flood-resistant construction. These adaptations are essential for resilience. Section 5. Technological impacts, Helene's disruptive force. Hurricanes can have a significant impact on technology and infrastructure, disrupting communication networks, power grids, and transportation systems. Helene's powerful winds and torrential rains caused widespread power outages, leaving communities in darkness and cutting off communication lines. Downed power lines and damaged cell towers made it difficult for residents to contact loved ones and emergency services. The disruption to transportation systems further compounded the challenges. Flooded roads and damaged bridges made it difficult for emergency responders to reach affected areas and for residents to evacuate. The disruption to transportation also hampered relief efforts, delaying the delivery of essential supplies and medical assistance. The impact on infrastructure extended beyond immediate damage. The prolonged power outages disrupted essential services such as water treatment plants and hospitals. The lack of clean water and medical care posed serious health risks to affected communities. The disruption to infrastructure also had economic consequences, impacting businesses and disrupting supply chains. The experience with Hurricane Helene highlighted the vulnerability of technology and infrastructure to extreme weather events. It underscored the need for resilient infrastructure that can withstand the impacts of hurricanes and other natural disasters. Investing in robust communication networks, hardened power grids, and resilient transportation systems is crucial for ensuring the safety and well-being of communities in hurricane-prone areas.